Hello students, in this topic semiconductor electronics, regarding the diode, that is analog circuits, and digital electronics we have discussed. Now the other part is transistors. This transistors part not covered, not asking in the JEE and also for KSET this year. They may ask next year, that is different, but for Neet purposes it is required. Most probability of asking for the Neet is there, possibility is there. So I am going to discuss these points for the Neet students only. If you are preparing for Neets, go through these points and no need to go elaborately into that. Only few final problems what I am going to discuss, that is enough for this topic. Transistors is the word taken from transfer the resistance. If input between the input and output resistance, the current faces the different resistance input and output of the device, and it is an electronic device used for the purpose of the amplifying the signals, increasing the size of the signals, and also switch on-off power supply switch also purpose also it is used. So transistor parts, it has three parts: emitter, base, collector. Just like the triode. Diode means 2 electrodes, so triode means 3 electrodes. So it is equivalent to the triode. It has three parts: emitter, base, collector. And these three parts, this part they may ask you, emitter is highly doped and able to provide the more charges. So it is emitting, we can say. And collector is the one which is collecting the charges. It is moderately doped and very lightly doped. Very lightly doped is nothing but low doping, or lightly doped is base. So highly doped is emitter, base is lightly doped, and collector is moderately doped. In between, doping is between that of the base, and emitter is for the collectors. And size in this emitter, base, collector, they are nothing but the semiconductor diode parts. Diode has a N and P, or PN we can call it as but here it has a NPN or PNP. So it is made as a single bar. So between N and P, if you take there is a junction. Between P and N also there is a junction. So two junctions are there in this transistor. It is also called as a bijunction transistor. There are many types of the transistors. What we have is only bijunction transistor. Two junctions are present in this transistor. And lengths, if you check up, length of the collector is very large compared to that of the emitter and base. Base is a thin, very thin. Base is a very thinnest of all. Very thin, so that very small amount of charges and small amount of current only passes through this base. But emitter is highly doped, can produce a large amount of current. And collector collect the charges, some current charges will pass to the base, remaining charges are collected in the collector. So collector current is very high compared to that of the base, but less than that of the emitter. Emitter current is always larger than that of the base and emitters. Length of the collector is very large compared to that of the emitter and base, and also has a more resistance for this collector part, and emitter and base have the low resistances compared to that of collectors. This transistor was first made by the three scientists, but names we just go through the notes. That's Schottky, Burton, Shockley and Burton. Next, types of transistors, BJT transistors. Bijunction transistors, there are two types based on the material we are using, either N type or P type. It contains compulsory N and P should be there, but which is the middle base, which is emitter collector. Based on that we have the two types. One is NPN, another one is PNP. NPN means P is in between of N and N, and PNP means means N type material means negative type material is between that of P and P. That means base, center one is related to the base. Base is here P type material, here base is N type material. Most widely used the transistors are of NPN transistors. NPN means what? In the N type material, majority carriers are electrons. P type material is majority carriers are holes. And again here majority carriers are electrons. Same thing for these cases. This is not equivalent to diode connections, but sometimes they will ask in the examination the similarities, comparisons. What we take is NPN. This is a PNP. P, this is a diodes. P type material, N type material. N type material, if you combine and take a junction connection output, it is similar to that we say, but it's not, does not act like a transistor. This is a P, N, and again joined N, P, NP, NP. Here we are taking this NPN. Similarity we can check up. But circuit symbol for the transistor, this is also important for us. Type of transistors, doping and length based related to the resistance also. Next is circuit symbols. This is a NPN transistor. NPN. This emitter is mentioned with the arrow mark, that is supplying the current or collecting the maximum charges coming. So this is the arrow mark is away from the base. Emitter, base, collector. Arrow is away from the base means that is supposed to be NPN transistor. Arrow is towards the base means that is supposed to be PNP transistor. And current passing through the emitter is called as emitter current. Current passing through collector is called collector current. Current passing through the base is called as the base current. In this case of the NPN transistor, the currents coming from this collector and base combined and passes through the emitter. Here, current coming from the emitter passes through the base and the collectors. Sometimes in the diagram, they may put a circle like this. That is only for the good visible show purpose only, nothing else, for no other reasons. Same diagram in the exam also they may ask you without a gap here between the base and emitter, they just mention from the single point also like this, and don't get confused with that diagrams. Next, biasing. Biasing means what? Giving unequal voltages or showing partiality is the literal meaning, is nothing but called as a biasing. For the diode we have the forward bias and reverse bias. Here for the transistor we have the two junctions between emitter base and collector base, two junctions are there. Emitter base junction act like a diode, ordinary diode only. The gap between these two voltage between this emitter and base, that is a barrier potential because the ionic regions. Ions are present here also, but this emitter base behaves just like the forward bias or diode after biasing. So here base emitter conditions, this is important again. How you bias it? Emitter base is always forward biased. This is forward biased. Emitter base junction is forward biased. It is just like a PN junction diode which is in forward bias. And collector base junction, this part is reverse biased. Collector base junction is reverse biased. This point you need to note. Next, block diagram. They don't ask this block diagram, but just have to understand. Till now they didn't ask, of course. You are biasing this emitter and base forward biased, and between this emitter and base you have to connect the battery. Resistance and capacitor connections also come in between. This is just a block diagram how the current flow. To understand that only we are taking this diagram. So here for the emitter base we take the battery connected producing the forward bias. Forward bias means what? N to N, P to P. So N and P junction we are taking, this junction we have to take. For this junction N and P, N should be connected to the negative and P is connected to the positive here. So it is forward biased. And collector base junction is reverse biased here. Collector base junction is reverse biased. For collector supposed to be plus terminals and emitter is connected, base connected to the minus terminal. This is N type, NPN, N should be negative means you have to connect to the plus, reverse biased. So this base collector junction is reverse biased, emitter base junction is forward biased. And current directions if you check up, now this emitter junction, here electrons will try to go from negative means electron try to go through this, and they try to go from minus to plus like this. But base is very thin and very few electrons recombinant with the holes. Here holes are majority carriers, electron majority carriers, electron majority carriers. But this is reverse bias. Current will not try to go here actually. But here forward bias current, large current passes and between this junction, at the junction between the emitter and base, we call this as a VBE. VBE, between the base and emitter, VBE. This part is forward biased. This is nothing but equal to the base and emitter junction. It is just like a diode and we call it as a VBE. Capital letters may be taken here. BE subscripted. This base emitter. Base emitter voltage. That is a barrier potential. How much it is for silicon? Barrier potential for silicon VBE is 0.7 volts. For germanium, if it is made of whole germanium or whole silicon is used for the complete transistor. If you are using the germanium transistor means VBE is going to be 0.3 volts. So here the battery voltage are connecting between these two two are connected here between the emitter base and between the collector base. Collector base we are taking the more voltage here. Series of the batteries taken here. Here in the diagram I draw the two plus minus means two cells in series. So voltage is higher than that of the VBB. Here current should be more voltage means more current, but reverse bias current will not be there initially. But here whenever the VBB is more than VBE, so this VBB must be, for the current to pass, the voltage VBB stands for base bias voltage, should be greater than VBE, more than 0.7 volts. Then only the voltage overcomes, then current passes through this. Like this is just like a forward bias of the diode. VBB, and this is going to be IB. Current passing through the base is called as a base current. Current is passing through this only when the VBB is more than 0.7 volts, and you will get the current passing like this. That base current is adding to this emitter current. This emitter side is coming like this. So input current is nothing but equal to base current, and VBE is exceeding only when VBE VBB is more than VBE, 0.7 volts it is, then current will be large. This is like a forward biased of the diode, same applicable for transistor for the first junction where it is forward biased, that is between emitter and base. And electron will try to go from this minus. Conventional current is opposite direction. Try to go from minus and this direction, and these electrons going recombine with the holes, but it is a very lightly doped, so few holes only recombine with the electrons. Remaining electrons attracted by the plus terminal will go in this direction. So some electrons go, this is the electron flow path, but conventional current path we take is reverse. So this electron path, so conventional current direction is, we take that conventional current direction from plus to minus, so opposite to electron flow. So current is coming like this, and some current is passing as a base current, this recombined to this. And to know this current directions for the base purposes, what we have to take is this VBB direction is nothing but equal to conventional current direction you have to take, and through this complete circuit the current direction you have to take is because of the holes. These electrons are coming here, so base current, electrons going here recombining and going like this. So conventional current is opposite direction. This whole conventional current direction is coming like this, and this current is joined and passing as a emitter current. So total current, emitter current is always equal to, emitter current is supposed to be equal to base current plus collector current. This is a conventional current direction, electron flow is just opposite direction you have to take. Same thing for the PNP. PNP. So P emitter, N is base. This is supposed to be forward bias. So forward bias means you take VBB plus to P minus to N for the base, forward bias. And collector is reverse bias, just opposite to the previous case. You can check up, this is a P type emitter means minus is connected. This is a collector connected voltage, this is a base bias voltage. And current direction you have to check up for this base, it goes like this, conventional current going here and recombine with some electrons here, holes, and few electrons are present because it is lightly doped and passes the current as a base current, and remaining current passes through this. So majority current go in this direction, small current go as a base current. So this is a conventional current direction I mentioned. Electron flow is opposed to this. This is a PNP biasing, this is NPN biasing. Just basic point you have to note, emitter base junction is forward biased, collector base junction is reverse biased. And total current IE is the total current, that is the maximum values. Collector current is some part of that which passes through the base, remaining will be passing through as a collector. So base current will be only 2% to 3% because lightly doped and very thin also. And collector current is more than that of the base current and less than that of the emitter current. Emitter current is 100% and 3% is base current, means 97% is IC. 97% of total current. Total current is 100%, that is IE we have to take. Next, uses of the transistor. It is used as two cases, switch and amplifiers. Amplifier means increasing the signal. When you are talking to the mic, your voice is very less, but loudspeaker sound comes out loud with more intensity. So that in that cases, the small signal what you are giving, this is your voice in the mic, and sound coming from the speakers will be very loud. The amplitude increased here means power is increased and voltage increased, current increased. That is called as amplification. Amplification is increasing the voltage or current or power with the help of this electronic circuit is called as amplifications. We cannot, actually we don't increase the voltage just like that, we take the help of the second bias voltage. The bias voltage we are taking the more voltage means more current. So always we will get the IC very large values compared to that of IB. This IB is the base called as input we are giving, and output is taken from the collector, not the emitter place. We are taking the collector, that is special case of course, but mostly we take is from the collector, output is taken because the collector current is more, output will be more for the small base currents. Amplifier and switch. Configurations. There are three types of configurations. One is called as a common emitter configuration, another one is common base configuration, another one is common collector configuration. Don't bother much of this, names itself gives a meaning for it. Common emitter. Emitter is common for both input and output. So this is the input, emitter, base, collector. Input is given between the base and emitter, and output voltage is taken from the collector and emitter is called the common base. Emitter is common for input and output. And we take the symbols for the common for terminal symbols, we take these earthing symbols, or this can be used for the common terminals or also considered as the earthing symbols. So this is the common terminals. Next is common base. Base is common for both input and output. This is a base, emitter, collector. We never give input to the collector. We always give the input either the emitter or base only. That is a rarely used connection. Mostly widely used connection is common emitter configurations. And base configuration is, this common base is only for the matching of the resistances between the two devices, two electronic devices. If you are taking called the transducers. Transducers convert one type of energy into other type of energy, like a speaker to the amplifier circuit or mic to amplifier circuit. The resistance do not match. When resistance matches, maximum power is transfer is possible. So for that purpose, we take the help of the common base configuration. Next is common collector configuration. Common collector configuration also very rarely used, only for the some switching amplifiers. Transmitter amplifiers not required for to know it. Collector is common for both input and output, but actually we don't give input here. We are giving input to the, it is common terminal only. Input is given at the base, okay, and output is taken from the emitters. Collector is common for both input and output. Widely used configuration is nothing but equal to common emitter configuration. And circuit diagram, how do you do it? This is not a complete amplification diagram here. This is like a switch you can take. Base is this is NPN transistor, NPN transistor, and between this is NPN. This is emitter, base, collector, and between the base and emitter the voltage we call as a VBE. Base bias voltage VBB we are connecting along with the resistance in series to the base. Sometimes the metal of this transistor material at the base also has some small resistance, very negligible resistance, that if it is given that you have to take in series with the RB, but that is neglected. So this RB itself we take it as a R in, called as input resistance. This base bias voltage VBB must be greater than VBE for the current pass from the base to emitter. Whenever this current passes, it is open circuit. It is like a closed circuit. Whenever it is closed, from the collector current IC also can pass. IC can also pass to here. If this VBB is less than VBE, then it is just like a open part. That means the diode is not completely forward biased, so current will not be there. Here current is 0 for the base. Whenever this VBB is less than VB, less than 0.7 volts, this part current will not be able to pass, just like a tap off on in between. So this IC cannot pass through this. Whenever the IC is not passing, what happened to the output voltage, you have to check up. For that purpose, we just one more thing is we have to check up this output circuit. This is the input part, this is the output part of the transistor. In the output part means for the collector biasing, we take the VCC, collector is here NPN, so plus, N means reverse bias, plus you have to take. So plus, and one resistance connected across along with the battery to the collector, that is called as a collector resistance. It is also called as a RL, means load resistance. It is also taken as output resistance. It is also taken as output. This part is input and output. So here output resistance is RC or an RL you take, and VCC is a voltage which is making the current to pass like this. Now condition I am taking is input voltage is more than VB. If current is passing like this, means IC can also add to this. Then VCC is supposed to be equal to IC, RC is the voltage across this. Remaining voltage across the collector emitter appears as a VCE. This VCE is the output we take from here. This is nothing but equal to, from here we take the output. So VCE itself we take it as a output voltage. Between the collector and emitter we are taking the output. Emitter is common for input and output. This is a common emitter configuration. Widely used configuration is common emitter configuration only. In any transmitters in the assembly you are taking the amplifier circuit is used. When you are talking to the mic, loud sound comes. That is because of this circuit diagram inside, that is a transistor circuit diagram. Next, applying the Kirchhoff's voltage law for the input output. This is what is crucial. This is only asked till now for the transistor problems for the Neet students, Neet exams. If you take the Kirchhoff's voltage law for this circuit and also for this circuit. For the input circuit, if you take a VBB is supposed to be equal to IBRB plus VBE. VBB is supposed to be equal to IBRB plus VBE. You can take B is small letter or capital letter. This is a constant value. 0.7 volts for silicon. I am using silicon material I am using for this whole NPN or NPN transistors. So in this case VBB is supposed to be equal to IBRB plus VBE. This part is constant. So VBB itself is taken as the input voltage. If you are connecting mic, then in series with VBB or parallel to that we have to take the connection for this mic. This mic voltage changes means that will be added to VB or subtracted from VB. This is called as a dynamic values. Dynamic means what? Variable values. When you take the variable values, we take the same equation as delta. That means delta VBB you have to use. Delta VBB means delta input we can use. And we write this as delta V in E is equals to delta IB into RB. VBE part what happens is 0 because VBE is constant, this part is constant. When it changes here taking means there only this part changes. The input voltage equal to delta IB into RB is the voltage across the input resistance. This for the delta term. Delta indicates means what? Change in values. If you are connecting the battery here along with this mic voltage, this is called as input voltage. This is a fixed value. So this one changes the voltage here. That is taken as a IB. IB is the base current, which is a very small current in the order of microamperes it will be. But large voltage you are using here, this current will, IC will be in milliamperes or amperes we can take. Next, applying the Kirchhoff's voltage law, loop theorem for the output part. VCC is supposed to be equal to ICRC plus VCE. VCC equal to ICRC plus VCE. VCE itself is the output voltage. So VCE, if we equated this ICRC, go to the right side, other side of the equation. So VCE itself is V out. VC out is equals to VCC minus ICRC. You will get negative sign here. VCC ICRC. So here, if VBB is greater than 0. Less than 0.7 volts. Sorry, first we will take the less than 0.7. Less than 0.7 volts. Then in that case, for silicon material, semiconductors, then current will be 0. IB is 0. Therefore, IC is also 0. Then what happened to this equation? Voltage is less than VBE. Then there is no IB. IB will become equal to 0. When IB is 0. IC is also 0. When this IC is 0, this part equal to current has to pass through this base only, but here open here, so current cannot pass. When current cannot pass, this IC is 0. When IC is 0, VC is equal to VC. That means output voltage, simply battery voltage comes. Resistance is counted only when current passing. When current is not passing, resistance is not at all counted. That means output voltage VCE, which is VO, becomes equal to VCC. That is a V out equal to VCC, maximum voltage you will get. In case if I am applying it as a variable comes, variable means you may be mentioned here as a arrow mark across this, here also may be mentioned as a arrow marks, or you connect a speaker output part. In that cases what happens, if you connect the speaker and the output, at that output voltage what I can, that is also changing in case if you have taken. Next case I am discussing is the input voltage is more than VBE, then what happens? This part what I am discussing is related to the switch. In the case of the switch, we plot the graph like this. This is the input voltage, this is the output voltage. Input is nothing but equal to, here we take it is equals to VBB plus Vin. This output voltage is nothing but equal to VC only. Whenever the input voltage is less than, V input is less than 0.7 volts, means VBE 0.7 volts for silicon or 0.3 volts for germanium. Then what we said is IB is 0, therefore IC is also 0, but output voltage VCE becomes equal to VCC, that is a maximum voltage. That means current is 0 but voltage is maximum, because current is not passing, the battery voltage only comes out as VCC. Voltage is maximum. But whenever the input voltage reaches to 0.7 volts, second case, if input voltage is equal to or greater than 0.7 volts, then output current starts passing. When current is started passing, then what happens? When there is the IB passing here, whenever that IB is increasing, forward bias diode you have taken, then IC also increases. Whenever this IC increases in this expression, IC increases means this part increasing, VCC is a fixed battery voltage, so this whole voltage decreases. That means this whole part decreases, VCC minus ICRC. IC increasing here, whenever the current is passing through this, IC also starts passing through this, and as IC increases, the V output voltage decreases. So output voltage gradually decreases. It does not become equal to 0, it just decreases to the value of, generally we take the biasing voltages 6 volts or 10 volts like that. So this will be reducing up to say 1 volt or less than that, very low voltage but not 0, and remains constant. Here current is 0, is called as a cutoff region. Here current is maximum, is called as a saturation region. In between the saturation and cutoff, here voltage is maximum. This is nothing but equal to VCC, maximum voltage, but current is 0. And whenever the biasing you have taken already, and input voltage increases beyond 0.7 volts, IC increases to the finally reaches to the maximum value, that is called as the saturation current. So if you are using only in the cutoff region and saturation region, means maximum current or 0 current, then it is called as a switch. That means input voltage. Input voltage is kept less than 0.7 or very high values. In that case, output current is either 0 or maximum, and voltage we are checking up here, current is 0. We have to extract only current actually. Voltage is maximum but current is 0. We are talking about the current saturation maximum only based on this current value, not on the voltage values. So this is the cutoff, and this is the saturation region. So whenever the switch cases IC is 0 is called as a cutoff, and IC is maximum is called as a saturation regions. What is the IC value? We can calculate from this relationship equations. This is RC. And in between regions is called as a active region. This active region is used for the amplifiers. Active region is used for the amplifiers, and other than active region is used for the switching purposes, transistor acting as a switch. Next, amplifier purpose, how to use this? If you are using this for the amplifier circuit, we take the output voltage by input voltage, output current by input current. The terms we are using is called the current amplifications and voltage amplifications. If you take the current amplifications, symbol taken as beta. Beta is equals to output current, that is IC by IB, base current. This is called as a DC components. And if you take a beta is equals to AC, this is called as the dynamic value. So the current changes you have taken, then it is called as the delta IC by delta IB, output by input. This is called as the dynamic. This is called as static. This means battery voltage, current only fixed value you are taken, but you are connecting the mic, speaker, if you are changing the voltages, then it's called the dynamic values. Changing delta IC means IC2 minus IC1 difference. Change delta IB also, IB2 minus IB1 changes you have to take. Next is this is current amplification taken with the symbol beta. Next is voltage amplification. Voltage is nothing but equal to V is equals to I into R. Similar formula you can remember here also. The output voltage by input voltage. Taken with the symbol voltage gain. Voltage amplification is also called as this part. Is also called as a gain. This is called as a current gain. This is also called as a voltage gain. What is this? Voltage amplification. AV subscript to V. AV is equals to V out by input voltage. Output voltage what you are taking is nothing but equal to VCE. That is related to V out by V in. Okay, let it be. But VCE itself is equals to V out and VBB plus V input. The variables, if we again same battery voltage you are taking, that only take it as a V input. But if you are connecting to the mic means that is taken as a input for the V input separate. In that case, if you connect the mic, don't use the battery voltage because it's fixed voltage. Only mic voltage changes added to this or subtracted from this. The resultant changes only because of the mic voltage, that separately we take it as a V in, only this part. V is equals to IR term we have, and we can also take the relation from this relation. V out, what is V out is equals to, when you are taking the changes, for the changes purpose if you take changes, if you are considering dynamic values, delta V in is equals to delta IB into RB, and delta VCC, if you take the delta output voltages, then you take the output, these are fixed values. V out values, if you check the change values means delta, but VCC battery voltage is constant, secondary battery voltage is constant, so take it as a V out, which is nothing but equal to VCE is equals to VCC minus ICRC. If you take the changes, if you have taken delta VCC means delta VO is nothing but equal to this voltage. Delta, if you take no voltage is constant for the battery, so no changes. No changes means delta is changes is 0. So we will get is minus delta IC RC. Only current is changing here as output voltage changes. So if you take the ratio of these two, voltage gain, output voltage by input voltage. Output voltage is, therefore we take it as voltage gain equal to V out by V in is also equal to this voltage gain. Voltage gain is nothing but equal to voltage gain or voltage amplification is output voltage by input voltage. Output voltage is nothing but equal to IC RC and input voltage is nothing but equal to IB RB. Collector side voltage into current. Current resistance is the voltage, input also current resistance and voltage. Input is related to the base and resistance of base resistance, and collector side output is nothing but equal to collector side collector resistance and collector current. This RC is taken as output resistance or load resistance. RB is the input resistance or base resistance. So voltage gain becomes equal to output voltage by input voltage, which is also equal to this IC by IB is nothing but equal to beta. Delta means variables, dynamic values to take. RC by RB is called as a resistance gain. It is called as a resistance gain. Current gain into resistance gain. Remember, you can remember the Ohm's law, V equal to IR formula. V equal to IR means voltage gain you are taking means voltage V place a voltage gain, I place current gain, R place a resistance gain, output resistance by input resistance. And what is the phase difference between the input and output? For the transistor input voltage, when you are giving the input voltage, you are getting the IC terms minus. If you give a small voltage at the input, at the collector output voltage, VC becomes equal to very large, but it is out of phase. So VC becomes equal to out of phase, it will be like this. So input voltage between the collector and emitter output voltage, the small input voltage you are getting means bigger output voltage, you will get voltage increases because of the VCC value is very large, but here the positive signal, if you plus signal means you will get the minus, means out of phase. What is the phase difference? This is also important question. Phase difference between input and output voltage is nothing but equal to input and output is 180 degrees or pi radians we can take. Next is power amplification. Power amplification, this minus sign also indicates minus sign indicates output is out of phase with respect to the input. This is output voltage by input voltage is minus. Next power amplification. Power is nothing but equal to, you can remember the basic formula, power in the electricity, power is equals to voltage into current, power is equal to I square R, power is also equal to V square by R. Similar conditions, if you remember that, we can write this equation easily. Power amplification is output power by input power, which is also equal to power equal to voltage into current, means voltage gain AV into current gain is beta. Or we can also write this as I square R means beta square into R means resistance gain RC by RB, or V square by R means AV square by R resistance gain. These are all not important ones, most probably power etc. they don't ask. They ask generally related to the calculation of the base currents and collector current or emitter currents. Next, input characteristics. Input characteristics related to the base and emitter. Base and emitters. Voltage and current. So whenever the base voltage is increases, base current also increases, base side. If the base voltage increases, base current also increases. This IB values, base milliampere we take, but VBE must be greater than VBE. Sorry, this is a VBB. Base bias voltage should be greater than VBE. What is VBE value? Is 0.7 volts per silicon, 0.3 volts per germanium. So more than this voltage is there only current passes, otherwise current will not pass. This is related for given VCE values we are taking, keeping the VCE constant. If you take a small VCE variation, they are not important for us. As VBB increases, IB also increases. Condition is that VBB is greater than base emitter voltage, that is barrier potential value. That is, this value is nothing but equal to VBE. They will give you the value of the VB for silicon and germanium, the problems. Next is output characteristics. Output characteristics the output voltage and output current. For the given base current, this is for the given VCE. So base current, if you have taken some value, then only IC can pass. If IB is 0, IC is also 0. Output voltage is maximum, but current is 0. So in this case, VCE, this is output voltage. What says output current? Output current is IC. For the given base current, if the base current increases, IC value also increases, but base current is in microamperes. But because single battery you are using, very low voltage will be there, but output voltage is very high values because IC RC we are taking as output relation, and also IC is large because of the output battery voltage is very large voltage you are taking. Due to that reason, IC in milliamperes means IB is microamperes. If IB changes, IC also changes. How that is changes? First IC increases and remains constant per the given voltage. The constant current is called as a saturation current. So this part is nothing but related to the saturation values. This is nothing but equal to cutoff values. When IB is 0, no IC will be there. IC is 0, that is called as a cutoff region. And because the minority carrier, some small amount of my current passes. We are not discussing with the minority charges. This is a saturation region, current here maximum values, and active region is this portion is called as the active region, used for the amplifier purposes, this part. So when IC changes, this IB changes, IC also changes, so voltage will be fluctuating here, and IC changes will be large values for the small changes in the base current that acts as a amplifiers. Because IC is large values we are getting, and voltage comes out to be IC into RC, so voltage increases in the output for the small changes in the input voltages. Next, problems. This is given in the notes, you can check up that. One circuit diagram is given here, and they are told the data is beta is equals to, for this transistor is 100, and these are not a static value, it is not dynamic, it is only static values. This is a VBE, and they told VBE as 0.7 volts, and the base resistance RB is 8.6 kilo ohms, and collector resistance is 100 ohms, and the collector VCC voltage is 18 volts, and VBB voltage is 5 volts they have given, and they are asked you to find out the VCE is how much, VCE or IC. Just have to check up what they asked. Okay, they asked VCE only how much. Applying the Kirchhoff's loop theorem or voltage law for the input circuits, 5 volts VBB is supposed to be equal to IB RB plus VBE. So we will get the expression beta is equals to IC by IB, beta equal to IC by IB, 100 they have given. Next, VBB, this VBB, apply the Kirchhoff's law, VBB is supposed to be equal to IB RB, this voltage plus this voltage is this applied voltage, VBB equal to IB RB plus VBE, VBE is 0.7, VBB is 5 volts, IB into RB is 8.6 into 10 to the power of 3 kilo ohms they mentioned, 10 to the power of 3 ohms plus VBE is 0.7, 0.7 take it to the other side, you will get a 5 minus 0.7 is 4.3 you will get. So IB into this value is supposed to be equal to 5 minus 0.7 is 4.3 you will have. IB we want, that is nothing but equal to 4.3 by 8.6 means 1 by 2. 10 to the power of 3 denominator take it to the numerator becomes equal to 10 to the power of minus 3. That means it is a 0.5 milliampere it becomes. Next is IC. IB we got. IC we have to find out from this relation. Beta equal to 100 which is equals to output current by input current, IC by IB. So IC equal to 100 into IB. IB we got as 0.5 milliamperes into 100. The result is 50 milliamperes. But we have to find, we are asked to find out what is VC. Then apply the Kirchhoff's loop theorem for the output circuits. This is for the input circuit. Next is output portion. In the output circuit what we have is VCC. VCC is equals to ICRC plus VCE. You are asked to find out what is VCE. From here to here is VCE, that is the output voltage. And VCE is equals to VCC minus ICRC, which is equals to VCC is 18 volts minus IC. IC we got equal to 50 milliamperes. 50 into 10 to the power of minus 3 into RC. RC is 100 ohms. 18 minus, this is a 10203 cancels 5, which is equal to 13 volts. Two more examples are there, please go through that, and gain resistance, gain voltage gain, current gain problems also you can work out from that material easily, but this is only for the Neet students. For other students, any other examination, competitive exams other than KSET, other than JEE, if you are going, then these are also helpful for you. Okay, we will stop here. Here students, the next part of the transistors. One more thing is that bijunction transistor. Transistor is also called as what in your syllabus is also called as a bijunction transistor or bipolar transistor, or short BJT. So don't worry much of this name, bipolar transistor. It also means the same only. Next is current gain. We already discussed the current gain for common emitter amplifier. Beta is equals to output current by input current, that is nothing but equal to IC by IB. This delta not mentioned means DC current. Delta is means delta IC, delta IB we can take. Next, for common base configuration, this is not in our syllabus actually. Input will be at IE, output is taken from the collector. Base is common for the both input and output. Then in this case, previous case, no, collector current is output, base current is the input we have taken. And this current gain for the common base configuration is taken output current by input current. This is also called as a reverse current ratio for the common emitter amplifiers. Common base amplifier is not in your syllabus, but still they may ask you these problems related with alpha and beta related to common emitter only. So collector current by emitter current ratio is called as alpha, and collector current by base current is called as a beta. Emitter current is maximum 100%, base current is very less 2% to 3%, remaining percent is nothing but equal to collector current, but collector IC is less than IE. Therefore, take IC by IE means the ratio is less than, alpha is always less than 1, beta is always more than 1. If changes in current gain means you take the delta here also, here also. Next is the relation between alpha beta is by putting these values into these expressions, you will get the relation 1 by alpha equal to 1 by beta plus 1. They ask only the formula or with the values. And alpha is equals to manipulating this equation, you will get alpha equal to beta by 1 plus beta, and or beta is equals to alpha by 1 minus alpha. Formulas, all the three formulas you need to remember, mainly for Neet students. This part what I am discussing for Neet students. Next is voltage gain of the amplification with a frequency relationship. As the frequency changes, how the voltage gain changes. The voltage gain first increases and then decreases and remain constant only for the particular frequency range. That is, these are constant terms. AB is a voltage amplification or voltage gain is constant only for the particular range of frequency in the diagram from F1 to F2. And frequency for the less than F1, gain is less, more than F2, gain is again decreases. High frequency decreases, low frequency decreases. If for DC you are taken means this frequency is 0, gain is 0. This was once asked, actually it is not in your syllabus that graph, but it was asked for the K-set also. But this year for K-set, this topic is not the transistor. This is for the Neet purpose students only, they may ask, so just for precaution I am telling. Next, input resistance, if you are taken, input resistance is input voltage by input current, VBB is VBB by IB. Output resistance is nothing but equal to output voltage VCE by output current is IC. Ohms only we can take. Reverse of this if you are taken as a conductance, that is Mohs you have to use or Simon you have to use. That will not be asked for you anyway. Next is current gain problem, one example problem. Alpha if it is given as 0.99, alpha is less than 1, 0.8, 0.9 like that they will give you, and find out the beta. Beta is nothing but equal to alpha by 1 minus alpha. Alpha it is 0.99 by 1 minus 0.99. 1 means 1.00 by 0.99 is 0.01. So decimal cancel it, 99 by 1 is nothing but equal to 99. No units for this alpha and beta. And in this they use a term called as small signal. Small signal means low frequencies. So again the small signal means low frequencies, and high frequencies signals they can relate to this gain. You have to check it up. When you are talking, our human frequency is only limited from 20 hertz to 20 kilohertz. But transistor can be used to amplify very high frequencies even beyond that audible range also for the transmission of the signals through mobile phone, etc. So that their gain is important. For what frequency the transistor amplifier circuit can be utilized. And input signal is out of phase with the output signal at the collector. This collector side what you get is magnified and reverse you will get. So phase difference is 180 degrees. This is at the collector. But at the emitter you will get the same relationship as the base. Emitter follows the base, means in phase you will find. Phase difference is 0. But here the phase difference is 180 degrees. Emitter side amplification will not be there much. It is possible to take amplification by connecting some resistance here, but don't bother much of that part. And at the base, sometimes in the circuit diagrams they may give two resistors here to find out the base voltage. Voltage division method you have to take for this R1 and R2 connected to the positive of the battery. This is connected to the base, I mean negative of the battery. Two resistors are given. Find out the VB at this place by taking the voltage division for the series resistances. That is a very rarely asked question. One more part I gave you in the notes for the transistor circuit diagram for the oscillator circuit they will mention. Oscillators. As the signal is given the oscillators purpose, LC oscillator circuit we have. In the LC oscillator circuits, inductance and capacitance we are using. If you charge the capacitor first, charge the capacitor and connect across the inductor. The charges try to discharge through the inductor, but inductor by back EMF sends the charges backwards. The charges oscillate to and fro, but they cannot oscillate for a long time because of the loss of energy by the resistance in the electrical circuit and also by radiation. Electromagnetic radiations, as the electrons oscillate, as they are accelerated, they produce radiations. Electromagnetic radiations come out. So loss of energy makes the oscillations to come to rest after some time. So if you want to continuously oscillate for a long time, what is done is we take the help of the amplifier circuit. Transistor amplifier circuit is used generally, or any instead of transistor, IC terms of integrated circuits are used. Integrated circuits are combination of the several transistors, diodes and capacitors, small tiny capacitors and resistances in the microscopic chip. Here output is taken, this is a V output, small amount of the output is taken and then given back in the input. This is called as a feedback circuits. We are taking small amount of the output voltage and given as the input voltage. So whenever here in this case the signal is decreasing. Now for this amplifier we are taking from output from outside, and we take this now for the collector, capacitor and inductors. Now this is a transistor amplifier. Small amount of the output now taken as the input for the base. This comes as the base current IB. Output current, what is decreasing, taken as input and given to the base. Again base is biased with the help of the resistors. So this signal what is coming here will add amplified again output. So output will be continuously coming out. This is called as the oscillators. And as the current, IC current again decreases, here decreases and increases continuously taking place. Amplifier, the small signal what is coming as amplified bigger ones, and continuously power is supplied to this LC oscillator circuit, so that continuously oscillates. If without the amplifier it cannot oscillate for a long time. So this is called as a feedback circuit. By mutual inductance you can take the high frequencies, the core is not used. Ferromagnetic core is not used for high frequencies. For low frequencies, ferromagnetic core is used. These two lines indicate the laminated ferromagnetic core. This is like a transformer, small transformer. Then taken the coil like this, and so one more coil taken near to this. This is going to be feedback. Very few number of turns you have taken means small amount of voltage given and small current is given, feed at the and given back. Feeding means giving food like at the base. That appears as a base current, and that base current again amplified as the coming out as a collector current as a magnified form. So, but here output voltage amplitude remain constant. Gradually the amplitude is decreasing here. The decrease in amplitude again increased, so that output remains constant. Output remains with constant amplitudes. Constant amplitude term you are using for the voltage and as well as current. Current amplitude or voltage amplitude means peak currents, because it's a variable AC you are using output for the oscillators. Oscillator circuits, they are called as oscillators. Oscillator circuits convert DC, battery power supply only you are using here, DC to AC. In the inverter circuit in the house, when the power supply goes out from the battery power supply, we are using it. Then the battery gives the DC only. The DC is converted into AC with the help of these oscillator circuits. And voltage will be less initially, but if you want to increase the voltage, you have to take the help of step-up transformer. Okay, with this topic is finished, and voltage gain problems I didn't discuss here. Only few problems, one or two problems only, just go through the material that I am going to upload.